Hello everyone, welcome back to this online class. My name is Francis Okech and my YouTube channel is Professor Francis Okech. So today we are going to look at Calculus 2 and our main topic is how to integrate integrals in which the integrand is a product of sines and cosines. For instance, you may have sine AX times cos BX. You want to integrate that with respect to x, or you may have sine ax plus sine times sine bx, or cos ax times cosine bx, where a and b are constants. So how do we go about such kind of integrals? So what we do here, we are going to rewrite the integrand using these trigonometric identities. So we make use of these identities. The first one is that, let me write, that sine A plus B is the same as sine A cos B, and then plus cos A sine B. Another one, we also know that sine A minus B is equals to sine A cos B minus cos A sine B. So if I want to know what is sine A times cos B, I want to know how to rewrite this integrand where we have sine A times cos B. So I'll add this equation, the right hand side and also the left hand side. If I add this one, I'm going to get sine of A plus B plus sine of A minus B should be able to give us twice sine A cos B. So I want to make sine A cos B the subject, so you can say therefore sine A times cosine of B is the same as 1 over 2 times sine of A plus B plus sine of A minus B. So that's how to rewrite sine A times cos B. So we are going to use this identity. It is half times sine of the sum plus sine of the differences, where A is associated with sine and B is associated with cosine. Another identity that we also know of is that of cos A plus B and also cos A minus B. So I can comment here that the restriction is that A is associated with sine. The A here is associated with sine, while B is associated with cosine. So that we now talk of sine A cos B. That's an identity that we make use of. Another identity that we require is this one. We also know that cos A plus B is the same as cos A times cos B minus sine A times sine B. Also, cos of A minus B is the same as cosine of A times cosine of B. Now the sign there is a plus. Take note of how those signs are alternating. Plus sine A sine B. So if I want to know what is sine A times sine B, and I also want to know what is cos A times cos B. So if I add these two equations, I am going to get this. I am going to get cos A plus B plus cos A minus B is the same as twice cos A cos B. And so make cos A cos B the subject, so you can say therefore cos A times cos B is the same as 1 over 2 cos A plus B. Then we have plus cos A minus B. That's another identity that you'll make use of when you have product of cosines only. You make use of this identity. That will help you rewrite the integrand in part 3 here, product of cosines only. What about when you have product of sines only? What do? That is sine A times sine B. I will now subtract. Instead of adding, I will now subtract. So this minus the other one. If I subtract, what will I get? I am going to get, remember I'm taking the second minus the first one. So I'll be having now cosine of A minus B minus cosine of A plus B should be equal to 2 sine A times sine B. Let me change this. 2 sine A times sine B. So I want sine A times sine B. Make it the subject. So therefore, sine A times sine of B is the same as, let me factor out negative. So it's negative 1 over 2 multiplying cos A plus B minus cos A minus B. I have factored out the negative. That's why I'm starting with the cosine of A plus B. So this is another identity that will help us integrate product of sines, sine A times sine B. So these three identities, let me take them. This is the first identity, the second one, and the third one will help us integrate problems where the integrand consists of products of sines and cosines. So I'll give you some examples, but before we look at examples, let's look at another identity that is very important for us. Another identity is this one. We know that, or we can just write take note that sine of negative A is the same as negative sine of A. Sine is an odd function. That means sine is an odd function. You can comment on it. This means an odd odd function. We also know that cosine of negative a is the same as positive cosine of a. That means cosine is an even function. So I can comment on this again. Even function. So these other identities will help us simplify our integrand. These are also very important. They are very, very important. So we'll use them. Now let's look at some examples. Example, I'll write it. So write example. Let's say you want to evaluate the following. In part A, we want to integrate sine 4x times cosine of 2x dx. We want to work out that. So what happens here, I need to rewrite sine 4x times cos 2x. What is this? How can we rewrite that integrand? Look at sine A times cos B is the same as 1 over 2 sine of their sum plus sine of the difference. So we are going to take note. Let me wrap what I've written here. We first of all rewrite that. So sine 4x times cosine of 2x. Remember now, this is A. A is 4x and B is 2x. Sine A cos B, that is the same as 1 over 2 in bracket sine of the sum, that will give us 6x, then plus, let's go back to the identity, the first one, sine of the sum plus sine of the difference, so A minus B. So plus sine, A minus B will be 2x. 4x minus 2x, that is 2x. So this is what you need to integrate. So therefore, this integral can now be written as the integral of 1 over 2 sine 6x plus sine of 2x dx, which is the same as 1 over 2 the integral of sine 6x dx plus another 1 over 2 the integral of sine of 2x dx. So we are going to use the u substitution. In the first integral, you let u to be equal to 6x. So that when you integrate it, we are going to get, in the first integral, we are going to get 1 over 2 times. Now ask yourself, what did you differentiate to get sine 6x? Derivative of negative cosine gives us, because when you differentiate cos, you get negative sine. So if you want positive sine, you have to differentiate negative cosine. So the answer here is negative cosine of 6x, but then you divide by 6, remember u substitution. And then the other one is 1 over 2. Again, here we'll have negative cosine of 2x divided by 2. Then plus a constant c of integration. This could be written as negative 1 over 12 cos 6x minus 1 over 4 cos 2x plus a constant c. So C there is a constant of integration. It is an arbitrary constant. And so this is our result of that integral. Another good example, let me call it part B. Another good example is this. You want to integrate cos 5x times sine 3x. Cosine of 5x times sine of 3x dx. Cos A sine B, or sine A cos B. Look at our identity. Our identity, where we have product of cosine and sine, we said sine A cos B. That is the identity we are using. So this can be written as, I want to start with sine. So this you can write as the integral of sine 3x times cosine of 5x dx. So this is your A, sine A, and with the 5x here is B. Sine A cos B. So sine A times cos B is the same as half, or simply 1/2 times sine of the sum plus sine of the difference. So this will be equal to the integral of 1/2 times sine, add them, 3x plus 5x, that will give us 8x. Plus, now A minus B, 3x minus 5x, so it is sine of 3x minus 5x, that will give us negative 2x dx. But I told you that sine of negative of an angle is the same as negative sine of that angle. So that this can also be written as, of course, you see 1/2 is a constant which can be factored out. So we have the integral of sine 8x minus sine 2x dx, which you can also write as 1/2 the integral of sine 8x dx minus 1/2 the integral of sine 2x dx. So that when you integrate, you're going to get the first integral. What gave us, what did you differentiate to get sine 8x? It was negative cosine of 8x divided by 8. So this will give us 1/2 times negative cosine of 8x divided by 8. Then there's minus 1/2, and the other one is negative cosine of 2x divided by 2 plus a constant c, of which if I simplify this one, I'm going to get negative 1/16 times cosine of 8x plus 1/4 times cosine of 2x plus a constant c. Every time you integrate and you don't have the limits of integration, don't forget to add the constant c of integration. Look at another example, 2 more examples. So we look at part C. Let me check this up or scroll it up. So in part C, you have the integral of cos 4x times cosine of 6x, cosine of 4x times cosine of 6x dx. What is it equal to? Look at cos A times cos B. We go back to our identity where we have product of cosines, and we found that the same as 1 over 2 cosine of the sum plus cosine of the difference. That's what we found. 1 over 2 cosine of the sum plus cosine of the difference. So I go back here and substitute. Remember, here, this is our A. I'll write that as, this is A. This other one is B. 4x is A, 6x, that is B. So this is the same as the integral of 1 over 2. It is cosine of the sum. That's 4x plus 6x, that is 10x. Plus cosine of A minus B. A minus B, that is 4x minus 6x, and that is negative 2x dx. And so we also know that cosine of negative A is the same as positive cos A, because we said cosine is an even function. So that this can also be written as 1 over 2 times the integral of cosine of 10x plus cosine of 2x, positive because cosine is an even function dx. Or this can be written as 1 over 2 times the integral of cosine of 10x, that is in bracket dx, plus 1 over 2 the integral of cosine of 2x dx. So then ask yourself, what did you differentiate to get cosine 10x? And also, what did you differentiate to get cosine of 2x? So in the first integral, let me use a different color. We'll have 1 over 2. Now, remember, when you differentiate sign, you get cosine. So here you will use U substitution to be able to integrate this. Let U be 10x. So when you work it out, you get sine 10x divided by 10. The other one is 1 over 2 times sine of 2x divided by 2 plus a constant c of integration. And so this can also be written as 1 over 20 sine 10x plus 1 over 4 sine 2x plus a constant c. That was very easy. And the last example is where we have a product of sines. Sine A times sine B. How are we supposed to integrate such kind of an integrand? So let me write it as part D. So in part D, we have this. We want to integrate sine 5x times sine x with respect to x. So check the identity where we have sine A times sine B. In this case, our A is 5x and our B is x. We said sine A times sine B is the same as 1 over 2 cosine of the sum, or simply it was -1/2 in bracket cosine of their sum minus cosine of their difference. So this can be written as the integral of -1/2 cosine of the sum 5x plus x, that is 6x. Then it was minus cosine of the difference. The difference here is a minus b, not the other way around. So that is 5x minus x, that is 4x dx, which you can also write as -1/2 times the integral of cos 6x dx plus 1/2 the integral of cos 4x dx. So what do you get when you integrate this? Of course, what gave us cosine? What did you differentiate to get cos? When you differentiate sine, you get cos. So this -1/2 times sine 6x divided by 6. Let me put this in bracket. Plus 1/2 in bracket sine 4x divided by 4, and plus a constant c of integration. So when I simplify this, the same as -1/12 sine 6x plus 1/8 sine 4x plus a constant c. So that is our answer. Look for more problems where the integrand is a product of sines and cosines. And take note of those three identities to be able to rewrite your integrand. So thank you all for watching. When we meet next time, we look at other forms of integrals. Don't forget to subscribe to my channel. Also, don't forget to like, share, and comment on this video. Bye-bye.